Welcome to the DIY Honda Garage channel. The DTC, Diagnostic Trouble Code P0843, refers to a malfunction within the transmission fluid pressure switch A, second clutch, circuit specifically for the Honda Odyssey models from 2011 to 2017. This code is triggered when the circuit is detected as open or the switch itself is stuck in the off position. The transmission fluid pressure switch plays a critical role in monitoring the hydraulic pressure required for shifting gears within the automatic transmission. Its location is found on the transmission assembly itself. When this code is activated, the transmission will default into a fail-safe mode, only allowing shifting between second and fourth gear to protect the vehicle's transmission from significant damage. The transmission fluid pressure switch A, second clutch, is designed to monitor the transmission fluid pressure, ensuring that the transmission engages the correct gear. This switch aids in providing feedback to the powertrain control module, PCM, which controls the automatic transmission functions. Its critical role is to detect changes in the fluid pressure and report these to the PCM, ensuring smooth transitions between gears. The switch is located directly on the transmission assembly, making it easily accessible for diagnostics, but requiring careful handling to avoid damage. When DTC P0843 is logged, it indicates that there is either an open circuit or that the switch is malfunctioning by being mechanically stuck in an off state, which negatively impacts the vehicle's performance. A few potential causes may be responsible for the P0843 code. The first is an open circuit within the wiring that connects the transmission fluid pressure switch A to the PCM. This could arise from damaged wires, corrosion, or poor routing. Another possible cause is a defective transmission fluid pressure switch, which may fail to change its state from on to off, thus affecting the readings sent to the PCM. Additionally, loose terminals or poor connections can result in intermittent signal loss, which again would trigger this error code. It is crucial to inspect these components thoroughly whenever the DTC P0843 is found, as identifying the root cause is vital for effective troubleshooting and repair. Drivers may experience specific symptoms when dealing with DTC P0843. One of the most noticeable signs is that the transmission may become stuck in gears other than second through fourth due to the fail-safe mode activated by the PCM. This limitation severely restricts the vehicle's performance and could hinder safe operation, especially during highway driving. Additionally, the vehicle may have poor shifting performance, resulting in harsh or delayed shifts that can cause driver discomfort and increased wear on the transmission. Warning lights may also illuminate on the dashboard, serving as a notification to the driver that a malfunction requiring immediate attention has occurred within the transmission system. Being aware of these symptoms can help in the early identification of issues related to DTC P0843. In the initial troubleshooting step for DTC P0843, it's essential first to turn the ignition switch to the on-to position without starting the engine. Once in this position, utilize the Honda Diagnostic System, HDS, to record all freeze data and any snapshots that may assist in diagnosing the issue. The freeze data will provide information on the conditions that existed when the code was triggered, such as vehicle speed, RPM, and other sensor readings. Following the freeze data recording, review the general troubleshooting information provided within the HDS, which gives detailed strategies on how to approach this specific code. Doing this initial groundwork prepares the technician for efficient and effective diagnostics, minimizing time spent troubleshooting. The next step involves clearing the DTC from the system using the HDS. This action resets the PCM and can help determine whether the issue is intermittent or persistent. Additionally, ensure that the rear wheels are securely blocked to prevent any movement while the vehicle is raised. Once blocked, the front of the vehicle should be lifted using either jack stands or a proper vehicle lift to ensure safety. The front wheels must be free to rotate, as this is necessary for later steps in the diagnostics when the vehicle is tested under operating conditions. This preparation step is critical as it provides a safe working environment to facilitate the next stages of troubleshooting. In Step 3, once the vehicle is prepared, start the engine and disable the Vehicle Stability Assist (VSA) system by pressing the VSA off button. This action allows for more precise control over the vehicle's performance during testing. Next, run the vehicle in second gear while monitoring the second pressure switch signal using the HDS within the automatic transmission (AT) data list. It is vital to ensure that the vehicle is accelerating and decelerating in second gear safely. Pay close attention to the signals displayed. These will indicate whether the pressure switch is functioning correctly. As the test is conducted, make sure the front wheels come to a complete stop, as this will provide a stable environment for the sensor readings. At this stage, it's crucial to verify whether the second pressure switch is on while in second gear. A yes response indicates an intermittent failure, meaning the system is functioning correctly at this moment. However, intermittent issues can be challenging to diagnose, so it is advisable to inspect for poor connections and loose terminals between the transmission fluid pressure switch A and the PCM. If the second pressure switch does not indicate as on, proceed to the next troubleshooting steps. Understanding this action helps to confirm whether the pressure switch itself is the source of the problem, or if it is merely an indication of connectivity issues elsewhere in the system. If the second pressure switch indicated as off, turn the ignition switch to the lock 0 position to ensure a safe environment while handling electrical components. Next, disconnect the connector from the transmission fluid pressure switch A, second clutch, to isolate it from the circuit. This step is crucial to prepare for the bypass test that will determine whether the switch itself is faulty. Before proceeding, ensure that the work area is clear and that precautions are taken to avoid shorts or damage during this diagnostic process. This methodical approach is essential to pinpoint the cause of the malfunction without unnecessary interventions. In Step 6, take a jumper wire and connect it between the terminal of the transmission fluid pressure switch connector and a reliable body ground. This action serves as a bypass to simulate the switch being closed, allowing the PCM to receive a signal as if the switch were functioning correctly. After setting up the jumper wire, turn the ignition switch back to the on-to position to prepare for testing. At this point, the HDS should be utilized once again to analyze the second pressure switch signal in the AT data list. This procedure is designed to determine if the problem exists within the switch itself or the circuit leading to the PCM, providing clear insight into the next steps for repair. In this step, check the reading on the HDS to see if the second pressure switch is reading as on. If it is on, this indicates that the switch itself is likely faulty and should be replaced to restore proper functionality. The transmission fluid pressure switch is crucial for correct gear shifting, and any failure could result in ongoing transmission trouble. However, if the switch is still reading off, this implies the problem lies elsewhere in the wiring or the PCM itself. Therefore, if the switch does not register, proceed to the next troubleshooting steps to further isolate the malfunction. After conducting the bypass test, Turn the ignition switch back to the lock, 0 position, to ensure safety while removing the jumper wire. Carefully disconnect the jumper wire from the terminal at the transmission fluid pressure switch connector. With the jumper wire removed, the next logical step is to investigate the connections at the PCM. Any issues, such as loose pins or compromised connections, need to be evaluated meticulously, as these are common causes of electronic communication failures within automotive systems. Proper functioning of the PCM is crucial for managing overall vehicle performance, including shift quality and responsiveness. For troubleshooting Step 9, the HDS must be used to jump the SCS line while ensuring that the PCM connector C, which has 49 pins, is disconnected. This action is vital in identifying whether there is a continuity issue between the specified terminals of the PCM and the transmission fluid pressure switch. The HDS serves as an essential tool for executing this jump correctly and enabling diagnostic capabilities that lead to accurate conclusions. Checking continuity is crucial because a break in the circuit would result in false readings sent to the PCM, causing the DTC 0843 to be displayed. Ensure that this check is completed thoroughly for effective troubleshooting. After completing all previous diagnostic steps, reassemble all disconnected components carefully to ensure that everything is securely in place. It is essential to do a test drive in various driving conditions to confirm that the issue has been resolved and that the transmission is shifting smoothly through all gears. During this test drive, keep an eye on the transmission performance and ensure that the DTC P0843 does not reappear. Finally, perform a last diagnostic check using the HDS to ensure there are no outstanding codes and that the transmission fluid pressure switch is functioning correctly. This final verification process is crucial to ensure that the repair was effective and that the vehicle is safe to return to normal operation. To prevent DTC P0843 from recurring, it is advised to conduct regular updates on the PCM, as software enhancements may improve signal interpretation and performance. Furthermore, regular inspections of the transmission fluid wiring should be prioritized, as any external damage or wear can lead to issues in functionality. Keeping connections clean and free from corrosion is equally important, as contaminants can disrupt effective communication between sensors and the PCM. By adhering to these preventive maintenance measures, the likelihood of future transmission issues can be significantly reduced, promoting the longevity and reliability of the vehicle's transmission systems. In conclusion, DTC P0843 indicates a significant issue within the transmission fluid pressure switch A, second clutch circuit that can adversely affect the vehicle's transmission performance. A systematic approach to diagnostics is essential for identifying the root cause of the problem, whether it be a faulty switch, connectivity issues, or wiring defects. Thorough steps taken to troubleshoot can lead to successful repairs and restore the vehicle to optimal functioning. Additionally, preventive maintenance is essential, as it not only addresses current issues, but also fortifies the system against future malfunctions. By staying proactive, vehicle owners can ensure the longevity and reliability of their Honda Odyssey's transmission system. Please like and subscribe to the channel. See you next time.